In this lesson, we're going to focus on the topics under the statistical analysis of quantitative data. Statistical analysis helps us make sense of numerical data, identify patterns, and draw conclusions.
We'll focus on four key areas: descriptive statistics, testing the difference of two means, correlation analysis, and interpreting statistical results. Each of these topics plays an essential role in analyzing data and making informed decisions. By the end of this session, you'll have a solid understanding of these concepts and how they are applied to analyze real-world data. So let's get started.
To begin, we will discuss descriptive statistics. Descriptive statistics help us summarize and organize data in a meaningful way. These methods allow us to describe the main features of a data set, such as central tendency, variability, and distribution. Whether you're analyzing survey responses or test scores, descriptive statistics will provide you with a clear picture of the data's characteristics. Let's start with the basic of central tendency and variability.
We begin with the measures of central tendency. These are the values that represents the center or the typical value of a data set. The most common measures are the mean, median, and mode.
Let's start with the mean. The mean is simply the average of all values in a data set. For example, if we have a set of numbers like 3, 4, and 5, we calculate the mean by adding them up and dividing by the total number of values. So, 3 plus 4 plus 5 divided by 3 gives us the mean of 4. Let's say we're calculating the average test score for 5 students in a class. Maria scored 70, John scored 85, Sophia scored 90, Liam scored 88, and Emma scored 92. The mean would be calculated as 70 plus 85 plus 90 plus 88 plus 92 divided by 5 equals 85.
Next, we have the median, which is the middle value when the data set is ordered. In the case of our previous example, since the values are already in order, the median is 4. But what if? What if the data set has an even number of values? The median is the average of the two middle values. For an even data set, James' test scores of 3, 5, 7, and 9, the median would be the average of 5 and 7. So it is like 5 plus 7 divided by 2 equals 6.
Finally, the mode is the value that appears most frequently in a data set. If we have a data set like 1, 2, 2, 3, 4, the mode is 2 because it occurs twice, while the others only appear once.
Now, let's move on to measures of variability. These measures help us understand how spread out the values in a data set are. The most common measures are range, standard deviation, and variance.
The range is the difference between the highest and lowest value in the data set. For example, if the data is 3, 7, and 8, the range would be 8 minus 3 is equals to 5. Let's say we have the test score of Ella, which is 50, Jake is 60, and Mia is 80. The range would be 80 minus 50 is equals to 30.
Next, we have standard deviation. This tells us how much each value from the datasets deviates from the mean. A small standard deviation means the values are close to the mean, and a high standard deviation means they are spread out. If we have the test scores of Olivia, 50, Aiden, 51, and Lucas, 52, the standard deviation is small because the test scores are close to the mean. But for the test scores of Emma, 30, Oliver 60, and Isla 90. The standard deviation is larger, showing more variation.
Finally, the variance is closely related to standard deviation. It's the square of the standard deviation and provides an overall measure of how data is spread out.
Now let's move on to testing the difference of two means. When we compare two sets of data, we often want to know if there is a statistically significant difference between them. This could be between two groups, two time points, or two different conditions. T-tests are commonly used for this purpose. And in this section, we'll discuss how to perform t-tests and what assumptions need to be met. We'll also explore non-parametric alternatives like the man-Whitney-U test and the Wilcoxon test, in which data doesn't meet certain assumptions.
Now, let's talk about testing the difference between two means. This section is all about comparing two groups to see if there's a significant difference between them.
We start with bivariate analysis, which involves analyzing the relationship between two variables. The t-test is often used in this case, and there are two types, the independent group t-test and the dependent group t-test.
An independent t-test compares two separate groups, while a dependent group t-test compares data from the same group at different times or conditions.
We also need to consider the assumptions of the t-test. For example, the data should be normally distributed and the groups should have equal variances. If these assumptions aren't met, we use non-parametric tests like the man-Whitney-U test or the Wilcoxon test.
In this section, we'll be focusing on correlation analysis. Correlation is used to measure and describe the strength and direction of the relationship between two variables. For example, we may want to know if there's a relationship between the amount of study time and test scores. Correlation coefficients, like Pearson's R and Spearman's Rho, helps us quantify these relationships. Understanding correlation is key to many fields, such as psychology, economics, and health sciences.
In this section, we'll explore correlation analysis. This is used to measure and describe the strength and direction of the relationships between two variables.
The Pearson's correlation measures the linear relationship between two continuous variables. It ranges from -1 to +1, where 1 means a perfect positive correlation, -1 means a perfect negative correlation, and 0 means no correlation.
Let's say we measure the height and weight of a group of people. John is 5'8" and weighs 160 pounds, Emma is 5'5" and weighs 150 pounds, and David is 6 foot and weighs 180 pounds. A positive Pearson correlation means that a height increases, weight also increases.
We also have Spearman's Rho, which is used for ordinal data or when the relationship between variables isn't linear. It also ranges from -1 to 1. For example, if you're ranking students in order of preference, Spearman's Rho can help us understand the strength of that ranking.
Finally, we will discuss interpreting statistical results. Once we've completed the statistical test, we need to interpret the results to draw meaningful conclusions. In this section, we will go over how to interpret commonly used descriptive statistics and inferential statistics. We will also explore how to report results clearly in the context of a research study, including understanding p-values, confidence intervals, and effect sizes. Knowing how to interpret results is essential for making sound decisions based on data.
In this final section, we'll discuss interpreting statistical results It's important to understand how to analyze and report descriptive and inferential statistics.
Commonly used descriptive statistics include the mean, median, and standard deviation, which help summarize the data. In contrast, inferential statistics like t-test and correlation analysis allow us to make inference about a population based on a sample.
In the results section, one should report the findings in a clear and concise manner, explaining the statistical test used and the meaning of the results. For example, after conducting a t-test on the test scores of Group A and Group B, we found a significant difference in their scores, with Group B outperforming Group A.
Today we've covered a variety of essential statistics